Hello, my name is Maria Hadlow and I am the Editorial Director of Lift and Hoist International. Joining me today is Ben Burgess. Ben is the co-owner and director of William Hackett. William Hackett is one of the UK's leading providers of chain products and lifting system solutions. Now, Ben, I understand that at William Hackett, you've become increasingly concerned about the lack of information around hydrogen embrittlement, and that you are endeavouring to bring that message of the importance of this issue to the market in general. Is that right?
Yes, that's correct, Maria. So a little bit of background here is we specialise in lifting solutions both onshore and offshore, two completely different set of parameters and requirements upon the lifting accessories. In terms of onshore, the weight, the environment is very much controlled. Offshore, that's completely different. And you add to that the effects of the corrosive environment and dynamic load amplification through the sea and the movement of the oceans and the currents subsea. So designing a product specifically for that has different requirements, particularly to deal with the hydrogen and the corrosion and what happens to the steel as a result of that. As the hydrogen goes into the steel, it can lead to embrittlement, which is a decrease in the product strength and working load limit over a period of time, which can then lead to failure. That's a brief little background there.
So Ben, how could a company know if products it was using was affected by excuse me, hydrogen embrittlement? Should we call it HE for ease?
HE is absolutely fine. So a number of products can be designed so that they can cater with the corrosion, and the product themselves can absorb the hydrogen within the steel structure without a degradation of the working load limit. But the short answer is that unless you know exactly what that product was specified as and for that environment, then you cannot be certain, because hydrogen embrittlement failures can occur through the corrosion where you can't actually see and examine the core product itself, but the failure happens from the inside out from the product. Very difficult to detect. So this is an industry issue that we're trying to raise so that the industry bodies and the manufacturers that work alongside William Hackett become better equipped at manufacturing products specifically for that environment. The fact that they comply to an onshore standard doesn't necessarily mean they're going to be fit for purpose offshore. And this is what we want to flag to the operators, the contractors, and the supply chain that supports the oil and gas industry.
So I see. So the fact that it's not easy to detect would imply that there have been some serious incidents that are caused by HE. Is that right?
Yes, there are a number of issues that have occurred over recent years, and I'll reference the ones where there's been public safety alerts issued through IMCA and other bodies. So Hoover Ferguson, who operate a fleet of containers for the operators and the contractors, they've had issues where they've had a grade 10, which is a particular grade of steel chain, and a number of their sling sets have failed due to hydrogen embrittlement. Same has happened with Modex in Norway. Same has happened with Swire in the Gulf of Mexico and in Trinidad. What has happened in these environments is that the manufacturer of the product has moved from a grade 8, which is perfectly acceptable, to a grade 10, which is acceptable onshore. But what we have found and what the industry experts recognize is that the harder the steel becomes, it increases its material susceptibility to hydrogen embrittlement. And this means that the grain structure of the steel is less able to accommodate the hydrogen molecules and atoms within the steel structure without degrading or maintaining the working load limit of the product. And it can crack inside out and under no load. So a number of these organizations have made policy decisions now to move away from grade 10 to grade 8. Our research and our product development endorses exactly that. Grade 10 is fine onshore. In our recommendation, it shouldn't be used offshore for this reason.
So you're saying that it's not enough for a company to look at the load conditions and specify an international standard product. You've got to look further than that if you are operating in these particularly hazardous environments. Is that right?
That is correct. And it's not straightforward. So firstly, that I would recommend that a user of these products looks at what the manufacturer is stating. Is it referencing that the product is designed for use offshore? Let's make the assumption that it is. The question then is, does the operator or the contractor have an obligation? Should there be a product failure, even though the manufacturer said it was suitable for this environment? There's a grey area, and there are legal cases going on at the moment regarding replacement of fleets of sling sets on this issue. So to my mind, they should look at, is the manufacturer stating that the product's designed for use offshore? Secondly, they should look at themselves whether or not the material and the material hardness is suitable for offshore. So as a rough rule of thumb, once you go above 40 Rockwell C, there's an increased risk and a track record of failures of lifting appliances. As you come down to there, and down, particularly down beneath 38 Rockwell C, then the number of failures become less. So we specify for our products different working load limits depending upon how the product is manufactured. But specifically, we recognize that you can't avoid the corrosion, you can't avoid the environmental stresses upon the product, so therefore you have to design it for a lifetime of use in the offshore environment, and so that the integrity of the working load limit is maintained.
So that sounds like you're suggesting that companies working in these difficult environments should enter into a dialogue with their suppliers and work with them to make sure they've got exactly the right products for their needs. Is that right?
Yes, but I reiterate that that is part of it. There is the issue about the supply chain, but there's also the industry. What we're trying to do here is to engage with conversations with the verification bodies and the international organizations so that people become more aware of this. So in this conversation, and the white paper that we will be sharing, shares with both those industry bodies and our competitors, in effect, what we think is best practice so that we raise the standard and the safety of lifting products in the offshore environment. So I think there's a two-pronged. One is what we do as an industry and as a set of manufacturers and verification organizations. And then within the companies themselves, I think there's some education to be done there that because a product meets a standard, is it suitable for use offshore? And just because it hasn't had a failure yet is no prerequisite that it will not fail in the future. The science must be applied, and what we know categorically, both in our industry and others, that the harder the steel, the greater the material susceptibility is to hydrogen embrittlement. And hydrogen embrittlement failure is catastrophic because there's no notice, there's no stretching, no external visual indication. It happens from the inside out.
And is it just the offshore environment that needs to be aware of HE?
So we specialize both in onshore and offshore. In terms of onshore, yes, hydrogen embrittlement can take place, but it's far less likely to, and to be fair, it's more likely to happen with stainless steel and other products rather than the typical alloy steels grade 8 and grade 10, because onshore you can still get corrosion, you can still work in difficult environments that can accelerate corrosion and the effects of hydrogen embrittlement as well. But I think the primary focus for this should be the offshore.
Thank you, Ben. Thank you for raising awareness of this issue. I think it will be important to very many of our readers and listeners. And with that in mind, we are hosting a webinar about hydrogen embrittlement that will take place on the 5th of November. And we will be presenting more information about that as we get nearer to the time. Ben, thank you so much for your time. It's been very interesting talking about this very important issue, and we'll be joining up soon to the webinar.
I look forward to that. Thank you.
Thank you.